Hello and welcome to the YouTube channel of Canara Engineering College. In this video session, we'll check regarding applications of op-amps, that is multivibrators using 555 timer IC. So basically when we speak about multivibrator circuit, this is an application circuit which is basically one of the very important application of op-amps. So before getting into what are these multivibrators or how basically this particular multivibrators function or how basically they are constructed, it is necessary to know the build and working of 555 timer IC. So if you want to know regarding a multivibrator circuit, it is basically a circuit which produces pulses. So if you can check out the definition here, the definition says that a multivibrator, like an oscillator, is a circuit with regenerative feedback which produces pulsed output. Pulsed output means it is something like this. So it needs to be producing the pulses. Based on the pulses, what this multivibrator circuit produces, they can be categorized into three major categories. One of the multivibrator circuit is called as astable multivibrator, second one is monostable, and the third one is bistable. When we speak about astable, as the name says, this is a multivibrator circuit which produces pulses, but none of the pulses are stable. So astable, which has got no stable state, but switches continuously between two states, which means that this is going to produce a pulse like this, something like this. So this will be, once this pulse is produced, it will become unstable and this is the pulse what is going to be produced. As soon as that is done, it is going to produce one more. It is going to produce one more, which means that none of the states of the pulses what is being produced by the multivibrator here is going to be stable. That's why we call it as a stable multivibrator. So basically multivibrator means it is an oscillator, a circuit which can produce oscillations. And the oscillations whatever is produced by this unstable multivibrator is going to be non-stable. Monostable means it is having one of the states to be stable. So probably if I consider this to be the stable state, one more state is going to be unstable. And again it is going to be stable state. And again it is going to be unstable. Again it is going to be stable. Again it is going to be unstable. So it says that one of the states is stable, but the other state is unstable. See here, you can see it is stable. It is continuously stable here, right? Whereas other state, it is transient. Transient means it is continuously increasing or spiking and going down, spiking and going down. So this is the second category of multivibrator. Coming to the third one, bistable. Bistable means the circuit is stable in either states. In either states means it can either be high or it can either be low, which means that if the circuit fires out to be high, then it is going to be high continuously, which means that it is going to be stable in the high position. Suppose if the circuit fires to be low, it is going to be low in the lower state, or at the zero state it is going to remain stable. This is what is meant by multivibrators, and these are the broad categorizations of your multivibrator circuit. Before getting into the multivibrator circuits or how they actually look like or what are the waveforms they are going to produce, it is very clearly said that you are going to design your multivibrator using your 555 timer IC. So we will check out how basically this IC or how the internal schematic of this particular IC is looking like. So if you check out the 555 timer IC, this is how it is looking like. So basically it is your 8-pin IC. It is an 8-pin IC with pin number 1 being the ground, with pin number 8 being VCC, pin number 4 being reset, pin number 3 being output pin, pin number 7 being the discharge pin number 2 being the trigger pin number 6 being the threshold pin, and pin number 5 being the control pin. So this is basically an 8-pin IC with 4 pins in one side and remaining 4 pins in the other side. This is how it looks like. So getting to the internal schematic of this particular 555 timer IC, It consists of two op-amps. It consists of two op-amps here. Basically, the op-amps, whatever we can see here, they form a comparator circuit. Comparator circuit means basically you will be feeding two voltages to that, and based on the voltages whatever you are feeding and based on the reference voltage what has been fed, the output of the op-amp will be standing as such, which means that it is basically comparing the two voltages, and the output of these two op-amp comparators are connected to a SR flip-flop. This is your SR flip-flop. The output of the SR flip-flop is connected to the output stage, and it is also connected to the discharge transistor. Discharge transistor means it is the transistor which will basically be discharging the output of the flip-flop when it is needed. And also you can see there is one more transistor which is connected, which basically works as a reset. Reset in the sense, if you want your flip-flop to be reset, if you want it to be cleared, you would have studied. A flip-flop normally will be having a reset, clear and reset pin, right? So if you want the output of the flip-flop to be set to 0, you can set this particular pin. So that is actually done via the reset transistor connected to the flip-flop. Also you can see there is a output stage. Output stage means basically it's a buffer or it's an amplifier what is connected here, so that whatever output is obtained from the flip-flop will be clearly visible at the output of this particular 555 timer IC. Also there is a discharge transistor which is used to discharge the capacitors which are connected in the multivibrator circuit, which we are going to check out further. At the input of this op-amp, you can see three resistors connected which are of 5 kilo ohm. This resistors basically work as a voltage divider circuit, or it basically works as a voltage divider resistors which help in setting the voltage to the comparators at 2 by 3 VCC and 1 by 3 VCC. 2 by 3 VCC at the inverting pin of the upper comparator and 1 by 3 VCC at the non-inverting pin of the lower comparator. So basically I told you, right, when I say it's a comparator, I need to give some reference voltages. The reference voltages are actually set by this particular resistive networks which are connected at the input side of the op-amp, and the reference voltage what is being set by this particular resistors will be given by this VCC. So basically the supply voltage will be divided as per the requirement, and they will be fed to the input pins of this particular comparator circuit which is built using the op-amps. So this is basically your 555 timer IC. So using this timer IC we will be building a multivibrator circuit. How it is to be built, we'll check out in the coming slides. See, the first one here, monostable multivibrator. As the name says, monostable multivibrator means it is having a single stable state. So monostable multivibrator using 555 timer IC. So here what we have done here is basically we have taken a 555. If you can check out, I'll just draw the broad lines here. So here, if you can check out the things what are inside, this is actually a 555 timer IC. An additional thing what we have connected to the 555 timer IC is we have connected a resistance RA and we have connected a capacitor C at the output side of your 555 timer. So resistance RA and capacitor C are the components which are connected externally to IC 555. Threshold voltage at pin number 6 and discharge at pin number 7 are shorted. That is, if you go back to the 555 timer IC pins here, that is pin number 7 and pin number 6, they are shorted. They are shorted here. Rest of the things are one and the same. You have the flip-flop, you have the comparator, you have the discharge transistor. So the discharge transistor what you have seen here, that has been shifted up. So this is your discharge transistor. Other than that, pin number 2, if you can check out pin number 2 here, where is pin number 2? Yeah, pin number 2 here is a trigger pin. Trigger pin is basically used to give the trigger input. To give some input, you use this particular pins. So you can see the trigger input which is connected to pin number 2. So this is your upper comparator and this is your lower comparator. So let's get to the working of this particular monostable multivibrator. Construction wise, you have no changes, okay? Construction wise, you take one resistor and one capacitor and connect it externally. Pin number 7 and 6 are shorted and that's all. You give the respective input to the trigger input of your 555 timer IC. That's all is the construction. Coming to the working of this particular IC, initially the flip-flop here, let's say that initially the flip-flop output is set to 1. Let's say that the initial flip-flop output is set to 1. When this flip-flop output is 1, transistor T, that is the discharge transistor, will be driven into saturation, and capacitor will be bypassed. Capacitor will be bypassed by this particular transistor, which means that the capacitor will not charge. So this transistor, when it is on, when the discharge transistor is on, initially when the flip-flop stores the data of 1, this transistor will be on and your capacitor will be discharged. That is, the voltage whatever is flowing here will be coming to this resistor and it will be, as this transistor is on, the old current will be flowing through this particular transistor. Therefore, the voltage at the capacitor will be 0 and the output voltage will also be 0. Even though it is containing a data of 1, the output voltage, which is basically the output which is obtained at Q bar, this will be 0. See here what is happening is, you are giving an input of 1 to the transistor, that is base current is given to the transistor and transistor is turned on. When the transistor is turned on, your voltage what has been given here cannot charge the capacitor, it cannot charge the capacitor. So your voltage will be getting flowing through this particular path, and your capacitor voltage will remain 0. When flip-flop is set to, or when as flip-flop is set to 1. After that what you do is, when you give the negative trigger pulse, that is when you give this particular pulse, when you give the negative trigger pulse is applied at the trigger input of the lower comparator, that is this is your lower comparator. So initially what you did is, nothing was applied, it was a stable thing, it was stable. After that your capacitor was not getting charged. After that what you do is, you start decreasing the trigger input. As you start decreasing the trigger input, here, that is when the decreasing trigger input is applied to the comparator, the circuit remains unchanged, no changes will happen in the circuit until the trigger voltage, or until the voltage what you have applied goes below 1 by 3 VCC. That is when the lower comparator voltage what is getting applied to the inverting terminal of the comparator, once it goes below 1 by 3 VCC, lower comparator output goes high. That is, the output of this comparator will go high and the flip-flop output will become 0. Flip-flop output will become 0, setting Q bar equal to 1. And the transistor T turns off. Obvious, right? As soon as you start applying the negative voltage to the lower comparator, or negative, as the trigger input goes negative, once the trigger input crosses 1 by 3 or once it drops below 1 by 3 VCC, this lower comparator will give the output which will set the data in this transistor equal to 0 and Q bar will be set to 1. Setting the data in this flip-flop equal to 0 will turn off this transistor, Once this transistor is turned off, what should happen? The voltage what has been supplied at the supply side should flow to the capacitor and the capacitor should start to charge through the resistance RA. Obvious, right? When this path is off, when this bypass path is off, the voltage will flow to the resistance RA and your capacitor will start charging in the exponential manner. We'll check the waveforms of this later. The output will remain high. The output of this particular output will remain high, or the output of this particular lower comparator will remain high for a particular time period, and that particular time period is called as T on. We'll get to this particular things once we get to this particular waveforms. Once we get to this particular waveforms. Now, what is happening? Your capacitor is charging, right? Your capacitor is charging. So you can say your capacitor is charging. Your capacitor is charging exponentially. Once the voltage of the capacitor reaches 2 by 3 VCC, once the voltage of the capacitor reaches 2 by 3 VCC, upper comparator output goes high. Upper comparator output goes high means S becomes 0 or S becomes 1, R becomes 0. When S becomes high, that is Q is equal to 1 and Q bar will be 0. At this instant, again T is on. At this instant again, my T will be on. As this T is on, what should happen? This path should get bypassed. This path should get bypassed. Later, what is going to happen to this capacitor? The capacitor should discharge to 0 and the output also should go to 0. Output at the Q bar pin remains low till the next trigger pulse is applied. So this is what it is happening. Continuously what is happening is, so initially let's say flip-flop is containing a data of 1. Data of 1. When this is containing a data of 1, this will be displaying 1. The output at the flip-flop will be 1. Because of this transistor will be on. And the voltage will be getting shorted here. Capacitor will not start to charge. Later what you do is, the trigger input whatever you applied, you will start applying the negative trigger input. When the negative trigger input crosses 1 by 3 VCC, the output of this comparator will go high, making R equal to 1 and S equal to 0. Once this is made 1 and once this is made 0, this transistor will turn off, thereby charging the capacitor. And the capacitor will start to charge until it is 2 by 3 VCC. Once it is 2 by 3 VCC, once that voltage gets applied to this particular comparator, output of this comparator will become 1, thereby bypassing the capacitor. And again, that bypass capacitor will be making the voltage flow through this particular path or flow through this particular path. Thereby, capacitor, what should happen? If the capacitor is not charging, what should happen? It should discharge. It should discharge. Until when it will discharge? It will discharge up till 1 by 3 VCC. Once it is 1 by 3 VCC, again it will start to charge, which means that this is how your monostable multivibrator is going to work. So basically it is all the work of the capacitor. During one stage, your capacitor will not charge initially. Later what will happen is your capacitor will charge. Till where it is going to charge? Till 2 by 3 VCC. Once the capacitor charges to 2 by 3 VCC, what should happen? It should discharge to 1 by 3 VCC. Once it discharges to 1 by 3 VCC, again your transistor is turned on and again the capacitor is going to charge. So this 2 by 3 VCC and 1 by 3 VCC is going to repeat in the monostable multivibrator. See, this is what is the circuit. I told you, this is your 555 timer IC. No changes has been done except RA and capacitor has been connected. Internally there are op amps and internally there are all the things. So initially, before you apply the trigger input, if you say the output is 0, your capacitor will not charge. After that, you apply the trigger input and when the trigger input crosses 1 by 3 VCC, output of the lower comparator will become 1, thereby cutting off the transistor, making the capacitor charge. Once the capacitor charges to 2 by 3 VCC, again the transistor is turned on and it is getting bypassed. It will get bypassed. See here, you can see, this is the trigger input. Once the trigger input reaches 1 by 3 VCC, your transistor is turned off and the voltage from VCC will be flowing to the capacitor, making your capacitor charge. Your capacitor charges to 2 by 3 VCC. Once it charges to 2 by 3 VCC, it will discharge. It will discharge. Once it discharges, you need to apply again one more trigger input here. Once you apply one more trigger input here, it will start to charge again. This output, what you can see here, this is basically the output of the flip-flop. If you can go back, the output will be 1, it will become 0. After that it will become 1, after that it will become 0. So that output is shown here. This particular time duration during which it will be on or during which your transistor output Q bar is high, that is called as T on. That is called as T on. And this I can call it as T off, during which there is no output available across the multivibrator. See, the derivation is given here. From the waveform of the monostable multivibrator, it is clear that the on time T on of the output voltage is same as charging time of the capacitor. Yes, obviously, right? So you can see here, when the capacitor starts charging, the output goes high and it will remain high until it starts to discharge. By the time it starts to discharge, it is off. And therefore, the T on time is the time taken by the capacitor to charge from 0 to 2 by 3 VCC. Quite obvious. So this is your 0, this is your 2 by 3 VCC. Whatever time that is taken by the capacitor to charge to 2 by 3 VCC is nothing but the on time of your monostable multivibrator. The voltage across the capacitor, which is a ready-made formula or which is readily available formula, is given by Vc is equal to supply voltage into 1 minus e to the power t by Rc, where what is Ra? R here, resistance is Ra, right? So let us replace Vcc is equal to Vcc into 1 minus e to the power minus t divided by Ra into C. At t is equal to T2, that is at turn on, the capacitor voltage reaches 2 by 3 Vcc. Obvious, at the turn on time is given by 2 by 3 VCC. So you can replace VCC is equal to 2 by 3 VCC, which is equal to VCC into 1 e to the power T on divided by Ra into C. And after resubstituting, you get the formula for T on is equal to 1.1 Ra into C. Or you can write T is equal to T on plus T off. Or you can write T off is obtained by T minus T on. So for a monostable multivibrator, the turn on time is depending on, or the time during which your waveform is going to remain in the stable state is given by 1.1 into Ra into C. So basically Ra and C plays a major role in making the waveform remain stable. If the capacitor is charging slowly, then obviously the stable state will be more. If the capacitor is charging very rapidly, see here, for example, let us say that it is charging here, then obviously your waveform will also become smaller. Suppose if it is taking more time to charge, then obviously your waveform will also remain stable for some more time. So basically the stable state of your monostable multivibrator depends on the value of Ra and C. So that is what is your monostable multivibrator. Basically your intention was to produce a pulse. That is what the monostable multivibrator will be doing. Thank you.